Namaste, Mata, Pita, Guru, Deva. Welcome back to Pine IT Edu Plus. Today's topic Principles of Decision Trees. Decision trees are a popular machine learning algorithm used for both classification and regression tasks. They are easy to understand and interpret, making them widely used in various domains like business, healthcare, and finance. Below are the key principles that form the foundation of decision tree models. Basic structure of a decision tree. A decision tree is a tree like structure where nodes represent decisions or tests on a feature. Edges represent the outcome of the decision. Leaf nodes represent the final decision or prediction. Components. Root node. The top node, which represents the entire dataset and the first decision point. Decision nodes. Nodes that represent tests on features or attributes. Leaf nodes. Terminal nodes that hold the output or prediction. Branches. Edges that represent the outcome of a decision or test. How decision trees work? Decision trees use a recursive partitioning process, meaning they split the data into subsets based on the feature values until a stopping criterion is met. General process. Start the entire dataset at the root node. Choose the best feature to split the data based on a certain criterion. Split the data into subsets based on the chosen feature. Repeat the process for each subset, creating decision nodes and recursively splitting. The splitting continues until a stopping criterion is met. Maximum tree depth, minimum samples per leaf node, no further improvement in splitting. Choosing the best split. The decision tree algorithm must choose the best feature at each step to split the data. Several criteria are used to evaluate how well a feature splits the data. Gene impurity. Gene impurity measures how often a randomly chosen element would be incorrectly classified. Lower gene impurity means better split. Information gain. Information gain is based on entropy, which measures the uncertainty in the data. Information gain evaluates how much information is gained by splitting the dataset based on a feature. Mean squared error. For regression problems, decision trees use mean squared error or MSE as the criterion to evaluate splits. MSE measures the difference between the actual values and the predicted values. The goal is to minimize MSE in each split. Tree growth and stopping criteria. A decision tree grows by recursively splitting the data. However, it's crucial to stop growing the tree to avoid overfitting. Overfitting happens when the tree becomes too complex and fits the noise in the data. Stopping criteria. Maximum depth, minimum samples per leaf, minimum samples per split, maximum features, max leaf nodes. Pruning the tree. Pruning is the process of removing parts of the tree that do not provide significant predictive power, helping to prevent overfitting. There are two types of pruning: pre-pruning or early stopping. Pre-pruning occurs during the tree building process. The growth of the tree is stopped based on certain criteria. It is used to prevent the tree from growing too complex. Post-pruning, coarse complexity pruning. Post-pruning involves growing the tree to its full size and then trimming back parts that are overfitting the data. The tree is pruned by replacing nodes with their majority class or mean value. The goal is to find the simplest tree that provides a good performance on both training and test datasets. Advantages and disadvantages of decision trees. First, advantages: easy to understand and interpret. Handles both categorical and numerical data. No need for feature scaling. Works well with nonlinear relationships. Disadvantages: prone to overfitting, instability, biased towards features with more categories, limited performance for regression. Hyperparameters in decision trees. To improve the performance of decision trees, several hyperparameters can be tuned. Following are the list of hyperparameters in decision trees. Conclusion. Decision trees are a versatile and interpretable machine learning model used for both classification and regression. The key principles behind decision trees are recursive splitting, the process of dividing data into subsets based on feature values. Feature selection criteria using metrics like Gini impurity, information gain, or MSC to determine the best feature to split on. Splitting criteria preventing overfitting by limiting tree depth, number of samples per leaf, or minimum samples for a split. Pruning removing parts of the tree that don't improve the model to enhance generalization. While decision trees are powerful, they can overfit and require careful tuning and pruning to achieve the best performance. Building decision trees in Python. Decision trees are versatile machine learning models used for both classification and regression tasks. We will cover the following steps in this video: importing libraries, loading and preparing the dataset, building the decision tree model, training the model, evaluating the model, and visualizing the decision tree. Importing libraries. To start building decision trees, we will need to import a few essential libraries. Scikit-learn provides the decision tree classifier and decision tree regressor for classification and regression tasks, respectively. Loading and preparing the dataset. We can either use an existing dataset or create a simple synthetic dataset. Here, let's use a classification example with a synthetic dataset. Building the decision tree model. We will use decision tree classifier to build a decision tree or classification task. The process is similar for regression where we would use decision tree regressor. Training the model. Once the model is trained, we can use it to make predictions on the test data. Evaluating the model. After training the model, we need to evaluate its performance. We can use various metrics depending on the type of problem. Accuracy score or classification. Confusion matrix and classification report. A confusion matrix is useful to understand the classification performance by showing true positives, true negatives, and false negatives. Visualizing the decision tree. One of the key advantages of decision trees is their interpretability. We can visualize the tree structure using plot tree from scikit-learn. Hyperparameter tuning. To improve the model, we can tune various hyperparameters such as the following. Conclusion. Building decision trees in Python is straightforward using scikit-learn. The steps include importing necessary libraries, preparing and splitting the dataset, building and training the model, evaluating the model using Key characteristics: binary splits, splitting criterion, handling of missing values, pruning, stopping criteria, can be used for both classification and regression. It is very versatile and can be applied to problems involving both categorical and continuous data. Key characteristics: information gain ratio, pruning, handling of continuous variables, boosting, rules, handling missing data, efficiency. Use cases: mainly used for classification problems, often used in business applications such as credit scoring, marketing, and fraud detection. Prediction by decision trees. Prediction using decision trees involves applying a trained decision tree model to new data to predict the target variable. Decision trees are powerful because they provide clear rules that can be easily interpreted. In this section, we will discuss how to make predictions using decision trees for both classification and regression tasks, including a hands on example using Python. Steps for prediction by decision trees: train a decision tree model, take prediction, evaluate the model, interpret predictions. Classification: predicting categories. In a classification task, decision trees predict a categorical target variable. For example, we may predict whether a customer will churn based on features like age, income, and account type. Regression: predicting continuous values. In a regression task, decision trees predict a continuous target variable. For example, we might predict a house's price based on its size. Interpreting predictions from decision trees. Classification: For classification tasks, predictions are made based on the majority class at each leaf node. The path from the root to the leaf node determines the class predicted by the tree. Overfitting and model evaluation. Overfitting. One common issue with decision trees is overfitting, where the tree becomes too complex and fits the training data very well but fails to generalize to new unseen data. That's all for today. We hope you found this tutorial informative and helpful. Detailed PDF notes available. Pay just Rs 49. Share the screenshot with video name and we will send you the notes. Google Pay number is given below. We are also providing online and offline classes on Oracle or MySQL SQL, PLSQL, Python Basics, and Python Advanced on all days from 4 am to 10 pm. For more details, please contact Mrs. Santhu Dinesh +919747006133. She will be available on WhatsApp also. If you have any feedback or suggestions for future videos, please let us know in the comments below. Your support means the world to us. For more videos and tutorials, please visit our channel Pine IT Edu Plus and subscribe. Don't forget to like, share and hit the notification bell. Thanks for watching and we will see you in the next video. Bye.